Hi, this video lecture we are going to discuss about the logical design of IoT. So IoT is network of connected devices which helps you to exchange the information through internet. So the logical design of IoT system generally refers to the abstract representation of the entities and the process without going into the low level details of implementation. So when I say logical design of IoT, we will be focusing on three aspects. One is the functional blocks and how the communication happens. That is what communication models which can be used by the IoT devices and the communication APIs which are available for the IoT devices. So these are the major aspects. When I say functional blocks, so these are all the functional blocks of IoT. You will be having some n number of IoT devices. Then management, you have services, you have communication, then you have security, and you have an application to interact. So these are all the functional blocks that provide the system the capabilities like identification, then sensing, then actuation, communication, and management. So these are all the major functional blocks of IoT. Next, when I say the communication models used by IoT, there are about 4 communication model which is being used. We will see in detail. First one is request response communication model. So here the client will be sending the request to the server. The server will process the request which in turn may be fetching the data from the resources, process the data, and then sends back the response to the client. So this is a request response communication model. Then the second one is publish subscribe communication model. So here you will have publishers, you will have brokers, and you will have consumers. Publishers are the source of data. They are the producers of data. And consumers are going to get the data from the publisher through the intermediate, that is broker. Okay. So the publisher or the data source. So this publishers will send the data or send the messages to the broker. In the broker, there will be n number of topics. Okay. So the messages will be sent from the publisher to the respective topics, and consumers will be subscribing to the particular topic. Say for example, look at the diagram here. Here consumer 1 and consumer 2 have subscribed for topic 1, and consumer 3 have subscribed for topic 2. It is not necessary that all the consumer has to subscribe for all the topic. So whichever necessary, the consumer can subscribe. And when the publisher sends the data to the topic, the corresponding consumer who has subscribed will receive the data from the broker for that particular topic. This is how the communication is established in a publish subscribe model. Then the third model is push pull communication model. So here the data, here again you have publisher, you have consumer. The publisher will send the message and this particular data will be pushed in the queue. And the consumer can pull the data from the queue. So here the queue will be acting as a buffer, and when there is a mismatch in the rate, say for example, the producer can push the data at some rate and the consumer can consume a data in a different rate. When there is a mismatch in the rate at which the producer pushes the data and the rate at which the consumer pulls the data. In that case, the queues will act as a buffer. This is push-pull communication model. And the fourth one is exclusive pair communication model. This is like a bidirectional. When I say bidirectional, both client and server can send and receive messages. So it is a bidirectional. When I say full duplex is like both can send and receive the data, and they will be using a persistent communication or persistent connection between the client and the server. So when I say bidirectional full duplex communication, here the client first initially will request for setting up the connection for the communication. Then the server will, once if it accepts the communication request, it will send a response to the client. Then the message will be sent from the client to the server. Then maybe the response can be received. You can send and receive n number of messages between the client and the server. And finally, when the communication is over, we have to close the connection. This is about the logical design of IoT, the different communication models used in IoT.